Fine. So what is the last class, guys? I think when we want to build a model and we do require the target variable in supervised machine learning algorithms, right? Okay. So by the way, and the target variable, it might be depending on some of the features and some of the features. So that features we can call it as the most important features, right? Okay. So and our task is that we need to identify or we need to be select the important features that we run all. Okay. Earlier, why? Going on. Let me close this folder and close this window. Visual Studio Code. It's Visual Studio Code. Okay. Open the folder.
Yeah, no, screen sharing was stopped.
Okay, yeah, there is some issue with. Let me share my screen now. Yeah, now you can see my screen, right? Let me go for detect. I'm selected this one. So let me import this pandas. There is some issue with this. Sure, right? Yeah. Okay. Now we are. I'm just running our previous statements because it is interlinked, right? Okay. And I would drop some of the columns and we have cleaned that info. Still have some kind of null values are there that we do either drop or else we can fill with those data. And after that one, we'll check that, is there any null values are there. After we are checking that, we are handling that categorical for that we are using label encoder. Okay. Yeah. So and we handle that this variable and get dummies, and this is how we are handle this data. Now we are copy that original data into one variable, and now I would convert mm, standard scaling, like all data it could be in the same range. And when we do this thing, like what happened? Yeah. So this is your data, right? Okay. So within this particular one, this true or false Boolean type, and for your converted into standard scaling and all, and this ticket and this name. Okay. And yeah, so those are the still it is a categorical kind of thing. Okay. And let's see. And we plot that, before scaling and after scaling also we plot that one. And moreover, for visualization purpose, we are using this methods. Yeah. So how the data it was distributed after scaling and before scaling. See, after scaling, you see 0 to 500 data distributions are there, but here 0 to 10, right? Okay. The range it was in a same range, right? Okay. So now, we, so heat map. So, why we are getting here error, because there are some variables are numbers, categorical kind of data is there. Okay. Make sure that this correlation it will works only for numerical kind of data. Okay. So you just without name and this one, we can try those things actually. Okay. And why we are getting that error, because some of the attributes are still it is in categorical. So when you plot that correlation for categorical, it is not possible. So that's how we can't identify that, how it was correlated to our target variable. For that one, we can use the chi-square test and all. Okay. Mm, let's handle that data actually. So instead of taking those all data, we have to consider, or we have to be give it only numerical kind of data. See here, name is object and ticket is object. So without these two, and we can try to be plot, or we can plot the histogram or else a correlation matrix. Okay. And we need to drop the non converted numerical value before we do any correlation kind of thing. Okay. Clear, right? So let's do that step actually. Only we need to select only numerical numeric features for correlation, right? Yeah. For that one, we do select D types. Just 1 second, guys. I'm getting a call. Okay. So we need to select the only numerical data types. So here we can say include called, so numbers data only. Only numbers data we need to be considered. Okay. So that one we can say it's a numerical data type features only. So this will include only numerical data type. Now we would like to plot the heat map. This heat map, with help of heat map, we can we can display this. histograms as well, the heat map, and so here we have to be give it our core method, the correlation method, and now it will work. It will retrieve the or it will be plot the only correlation between the numerical things. Correlation matrix. This correlation matrix will simply help you for identify and how and what features are independent to might be depending on another one, and what the features are it was independent itself, so that we can easily identify with help of this correlation matrix. So careful observe here actually. So even there is no use of the passenger ID, but just I don't consider this one actually survivor, right? So this is the survivor, and which relation with passenger ID? It's a minus 0.005. There is no relationship between the survivor and passenger ID. Okay. Next, survivor and survivor, it could be one. That means strong relation. And survivor versus P class. So P class in the sense some kind of categories, right? Like which class they were booked the ticket and all. See, negative minus 3.4, negatively correlated. That means in terms of survival, so it could be negative kind of thing, but it's a kind of relationship, right? It's a kind of whether it is a positive or negative, it doesn't matter, but it have some kind of relationship, right? Okay. And in terms of age also, it's having some kind of negative relation. Okay, minus 0.54 in the sense it have some kind of relation. And in terms of age is 7% is there. The next one is CBHP and Park and so fair. So these are the features. These are the features are some of the features are independent to. Sorry, some of the features are dependent for this particular feature, but meanwhile we can cross verify rest of things as well. So might be this particular p class it is having some kind of relationship ship with age, as well as yeah, and moreover this fire fire as well. So see here, independent features also, it might have some kind of relationship with another independent variables, that we can call it as the multicollinearity. So when we have multicollinearity problem, in generally linear kind of uh, problem statements, it is not good thing to consider the two different features are correlated to each other. Okay, so of course our target variable and our independent variable having some kind of positive or negative correlation, it is fine. But when your independent variables versus independent variable, if we have some any kind of relationship, which it could be either positive or negative, so instead of considering those things, then we can consider any one of it actually. That's how also we can able to identify what are the features are important, what are the features are not important. Okay, is it clear? Yeah. Hello. Okay. So with help of correlation matrix, what we do, we can identify what are the features are important and what are the features are not important. Can you please note this one? If you don't, please let me know.
Yes, completely.
Okay. So I think I have shared with you for feature selection, we have using various methods, right? Hmm? So no. And so here, when we are working with numerical kind of thing, this correlation it could help you. But what about categorical? So when your data set, it might have some kind of categorical kind of variables also we have it, right? Okay. And it might be a categorical input independent variables you might have it, as well as a categorical target also you might have it. So that scenario, and so we do use in generally chi-square test. If you want to check that, how correlated, how categorical variables versus categorical variables, for that one we can use the chi-square test. With help of chi-square test, we can easily identify how strongly those categorical variables are independent to each other. Okay. And see, for example, I'm taking that my dependent variable is my x. Okay, my y variable is my dependent variable. Okay, df of server. This is my y variable. Okay, I want to take my x variable also, and this x is my independent variables. I would like to drop the except server. Everything I want to be considered um is my okay. Except survivors, everything I'm considering my input variables. Okay, so that is the reason I'm just dropping that one, and the rest of things I'm considering the okay, my independent variables. That independent variables I'm consider as the x variable. Okay, now what we have to do, we are just simply okay convert everything into numerical, and I'm just consider everything it could be categorical. Okay, just we are provided that encoded, and so pd dot get dummies, so get dummies. Okay, we just provided your x variable. If anything is categorical, then automatically it could be converted. Okay, and after that one we have one method we required. That method is select the k best and k square, so which is available from your scikit-learn. And so feature selection, so we are going to be selecting the features, right? So feature selection, and so we are going to importing the chi-square, chi-square. So this one we are going to be using if you want to be find the relationship between categorical variables versus categorical variables and rest of things. Okay, best. Okay, so these are the things we generally we could use it. So, and with help of select k best, then we are going to be selecting the best things. Select k best, and score function is, so we are core function, and we are going to be using chi-square too. And so we are going to be finding that um, five things, and so we are going to be taking that all selectors. So here we have, can take any variable. I'm just taking that selector. Okay, so this selectors we have to be transform it, fit transform, and so your x encoded. Okay, so now this is your x new variables. Okay, so now we are transformed, right? So with help of this one, we can just see that what are the selected features, and that too it's a categorical kind of things. Now let's see selectors and get support with the help of get support, and we are giving indices as well, so that way we'll get some kind of index for those things. And so I'm taking that new things. Those are my selected columns. What are the selected columns? I'm just displaying those things. I would like to go with print the selected columns. Selected columns. Okay. So it's encoded and from the columns. Okay. And we have to be take only selected columns. So if you run this one, it will retrieve the okay. There is some kind of null value is there. See there. Yeah, we are not handled this age. Okay, that means you are not run this statement. You missed it somewhere else. Missing. Where it is available? Okay, that's right. Okay, now let's let's run. Let's see now. Now we handle right. Yes, we handle all missing data. Now we can run it. X must be non-negative. Yeah. So see what happened in our data set. I have used the um have applied some of what we call scaling kind of technique I applied, right? Because of that one, my data which is having some kind of negative data also, and so which is not supporting the negative kind of data. So what I do, I have to be take it only some of the columns, important columns only I'm considering the okay X variables. So I'm just taking individual things like yeah, take it uh, P class. Oh, okay. Mm, okay. So P class is my category. I'm just considering this is my category and name ticket token ticket like uh, we already handled that categorical because of that one, which is converted into the numerical. Okay. And but in generally, if you're not converted, if you not handle that categorical, and if you try to do that, yeah. So I'm just taking only few things actually instead of taking all the things because some of or having the um, categorical kind of thing, right? Okay. Non-string sequence. Yeah. So there could be some kind of issue, guys. We have to handle this one, but in generally, what is my thought process is here, and you need to be give it only get dummies. Let's see. Let's see. X and I'm taking X over here. Yeah, there could be some issues there, like I have to handle properly because our data, which is not supported this string kind of thing. But that is a one approach, like chi-square is a one method. And second one is a wrapper method. And next one is wrapper method. So with help of wrapper methods also, we can identify or we can find the best or the important methods. We can select some of the important methods. And so from the wrapper method, we do have one method is RFE. RFE means what? It's a recursive features elimination. Okay, feature elimination. Okay. Recursive feature elimination. See, when we can use it actually. So when we have a small to medium kind of data set, if we have it, so then that scenario we can use the recursive feature elimination. Not too much large actually. Your data set it could be small to medium range only. Then only we can apply this kind of recursive feature elimination. So for this, if you want to apply this RFE kind of thing, so we do have one direct RFE class is there that we can import. So how it will works, and I can tell you. And feature selection. And so from here we have RFE. So from RFE also we can select some of important features. And from scikit-learn for that we can use the linear model because we are going to be considering the our data set which is a linear model supported thing. And for that one, we do use logistic regression machine learning. So from here only we can get that RFE things. First, we have to go for create the models, and don't worry how the logistic regression is working. I can tell you in later on sessions. I'm just showing you that for feature selection also some of the machine learning models it could help you. Okay, so I'm just creating that the model for that. Okay, and so RFE, so we can take that in RFE class, and we are giving this particular model, logistic regression model, and n features. So we have to attribute n features to select how many features you want to be select out of your data set. Then we can give it like f. It's up to you number actually. So what number you want to give it? Okay. So if you required five features only, then you can take it. Give that value is a 5 only. If you need 10, then we can give the 10. If you have 1,000 features, out of 1,000 features I want to select the and five features after all the eliminations. Okay, that one we can do. So this RFE we have to be fit it. And so oh, mm, 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 okay, so we are taking that mm, it's encoded, and we are provided that your y variable. And so we can able to print the selected features as well. So guys, the code wise, it's a very simple things. We don't need to think too much about it. So which is direct methods we can use it. So features, selected features. And so here we can have X encoded. And now uh, fit, okay, so fit, and we can fit support. So okay, so with help of this one, what are the things which was supported? Those things we can able to retrieve it actually. Federations scale automatically it will do. This is the one method. So recursive feature elimination is the one method to select the important features. and in your method, in your model building. And next one is embedded methods. We can use various methods as well. Those things, embedded methods. So previous one is RFE. For RFE, we can use logistic regression. For embedded methods, so we can say that it's a random forest feature importance. So random forest, we can use the random forest feature selection also, feature importance. Okay, with help of this one, we can easily identify the important features. Okay, and for that also we can import our random forest classifier, so which is available in um, Ensemble. These are the ensembling methods. See, I've not started any kind of machine learning algorithm so far. I'm just giving that, before we build any machine learning models, make sure our data, it should be ready for that. So for even for selection process, we can use some of the machine learning algorithms. So that's the reason I'm not giving more information here. And so I would talk machine learning algorithms, machine learning concepts from Monday onwards actually. So where we can use and why we can use it, I'm just showing you here. Okay. So next one is we need to use the random forest classifier. We can use random forest for both classifier as a regressor as well. And now we would like to be go for build the model, and for create the model we can use the random forest classifier. Okay. And then, what we do, we have to fit your model with your data. So fit and X encoded. This is my X data, and I have Y data as well. And with help of this one, now we can model has been trained it itself, and so we can collect the important features, important features we can collect. Like how do you collect actually? So the model, it could give you direct attribute, which is a feature importances underscore. So this will give you like an important features. Okay. And so that's how we can collect those things actually. Now what we do, we have to be create some kind of uh, series like PD and series, so we can convert all into one area. Like we are taking that your importance columns here, and so here I am giving that index equal to our X encoded. So each and every column, it will be act as our index, and importance values, it could be another so you will be getting that table was created, and index is our column names, and the corresponding important things, important value, we will get it the right side actually. And so that's how we are going to be creating one data frame or a series, the series of the panda series, we can call it as the feature importance. So this particular one, then this particular method, it will give you the important features series, we will get it out at. Okay. And even if you want to plot those things also, we can plot it with a simple thing. And for feature importance, and large and largest, and we are taking that 10. So we are split up 10 things and plot. It could be what kind of plot you want to be give it. It's kind of bar. Okay. Okay. So we would give you plot title. So the title is, it's a top important features. Top 10 im- top 10 features. So these features are most important features in our perspective. So we can fine tune it also, whether this particular model, it will be work or not. But this is the way of do actually. Okay. So this is how we can do it actually. Okay. Even length of values or one does not match the length of index. There could be some issues there actually. So I'm just showing you the rough code for that. There could be some kind of issue with our data that we need to handle before we do. Okay. And yeah, I hope you understood, right? Different methods we do have it actually. One is embedded methods and one is wrapper methods, or either we can use a chi-square when we have categorical kind of data. Or if it is a numerical data only, we can use correlation. So with help of these features, with help of this methods, we can identify or we can select the important features. Okay, is it clear? Is it clear or not?
Yes.
Yeah. Okay. So far, we understood that handling the missing data, handling the categorical data, and mm, feature scaling you understood, and feature selection is also you understood. So feature selection before feature scaling only we have to do it actually stepwise. Okay. So some situation what happened, because of this numerical negative things and all, we are unable to do it actually. So even feature scaling is not applicable for all the data. Okay. So feature scaling, it is applicable for only some of the features only, not all the features. Whatever the features you scale it, don't use it for those things. For mm, before that only we can apply the feature selection. Okay. After that one we can scale it. Before we apply the machine learning model, we can apply the feature scaling. So yeah. So that's for the basic stuff of data processing, and we do get more details in later on sessions as well. And but from Monday session and machine learning class, what I do, I would try to be start implementing or start explaining the basic machine learning algorithms from the simple linear regression, multiple linear regression, and lasso regression, ridge regression, and um, and meanwhile logistic regression, support vector mission, KNN, k nearest neighbors, and decision tree classifier and regression, random forest regression and classifier, XGBoost regression and classifier. This all machine learning algorithms. First, I can explain you theoretically. Theoretically means how that particular models are working, how that algorithms are working, and I can explain you first. After that one, we can take one particular data set and we can directly apply the machine learning model without doing this all data processing. Okay. After completion of the all the regression and classification and clustering kind of things, then we can do one or two projects, either full end-to-end projects. There, from there, we need to know how we can generate the data, data collection, data process, data extraction, transforming, loading, and after that one, data pre-processing, and features selections, and model building, model evaluation, and model deployment. The end-to-end things, at least one or two projects will do it practically. Okay. So for that one, we are going to be using the Azure cloud for storing the data. I mean, and for building the models and all, we can use Azure machine learning. Okay, either we can use Visual Studio Code also in a local. In some situation, if data is too much large, then we have to use the directly on the cloud. Okay, so once I completed the all the machine learning algorithms with basic stuff in my Visual Studio Code, after that one, I will do one end-to-end project. It will take um, I won't take much time because I know I would implement it before I explain. Okay, and that I can show you how we can do, and that entire workflow I can show you practically, so that it won't take much time. Just if you spend like a couple of 2 to 3 hours, then definitely we can get it some idea of that particular project. Okay. So once I completed all the concepts which belongs to the machine learning, then only I will do that particular project. Clear? Then only I will show you that particular project. Once I completed the one project from the machine learning, then we have to use same process for rest of things also. Rest of things means if I completed deep learning concept, then we can apply one more project using deep learning on the same set of services from the Azure. Clear? Clear, right?
Yeah, okay.
Yep. Yep. So meanwhile, we can try to habituate it with Azure cloud. Don't take any cloud environment for 1 month of free trials at this moment, because when real, if you took the 1 month free trial right away, then what happened? Whenever I started explaining of the project, that time you can't practice because your 1 month trial, it might be lose it, right? Okay. So either if you're the student, still you're the student, then what you do, you can create your own account from the Azure for the student. It will have 1 year of a free subscription, and there you can get the 200 credits. Then we can use some of the services also. Okay, and yeah, you're fine. Yeah, that's it from my end, guys. And I hope you enjoyed this particular session. And and Monday session, what I do, I would start the machine learning algorithms. Okay.
Yeah, then where these classes are storing? I mean, where these classes are uploading? Actually, previously it is stored in like in YouTube. Still the same platform or
See, I'm uploading into the I have given Canvas access, right? LMS. Canvas is the LMS we are using now, and within that Canvas, I will show you how it will. Okay. Not aware of those things. I already explained the first class itself.
okay? Could you please share the link of that one LMS? Actually, I am not aware of that.
Let me show you first. You can see this one, right? Dashboard.
Yes, yes.
Here I'm uploading actually. So the machine learning class recordings I'm uploading here itself. Okay. And if I explain Python, the Python concepts I upload here itself. Okay. So this you will access. Let me stop my recording.